Today we're going to talk about circles on the coordinate plane. First, let's talk about our circle vocabulary. Our center, our blue dot right here, is our point at the center of the circle. Our diameter is a line segment that passes through the center and the endpoints are on the circle. The radius goes from the center to a point that is on the circle. The radius is exactly half of the diameter. So when we have our picture of a circle here, we have our center, our blue dot right in the middle. We have our diameter, our purple line segment here that goes from one edge of the circle all the way to the other, and it goes through the center. And then our green segment here goes from the center to a point on the outside, and that's our radius. So when we're talking about a circle, we're not talking about the entire pie. A circle is kind of like our pie crust, so just this outer ring. So a point that is in the circle are not on the circle. If I look here, I have a point on our pie crust that's on the circle. The point in the pie here would be in the circle and not on the circle. To name a circle, we name it by its center. So here we have center C. So the circle's name would be circle C. We're asked to name a diameter in the circle. Remember, our diameter goes through the center and it has a point on both endpoints are on the circle. So I have AE goes through the center and both endpoints are on the circle. I could also call it EA, and that would be correct as well. For a radius in the circle, I have point CB. It's the one that stands out to me first. I could also call it CB, or BC. We also have two others. We have CA, so that's half of our diameter here. That would be a radius. And CE would also be counted as a radius. But here, we're only asked to list one, so we only need one. Number 3, if we look at point B is on the circle. And if we look at point F, it is in the circle. When we have circles drawn on the coordinate plane, I have a trick I can use to find my center and radius. If I look here at the very widest point and I draw across the grid line, and then I look for my tallest point, and I draw a line down the grid line. Where I cross over here, it meets at the center. So to get the radius, because I can count directly across the grid lines and I'm not counting a diagonal, then I can take any of these 4 points and I can start counting to the center. 1, 2, 3. So I count from on the circle to the center of the circle, and that is 3 units. So that's my radius. For our center, here, my x value is 2, and my y value is 3. So 2, 3 would be the center of my circle. We're going to do the same thing for number 2. We take our widest point, and we draw a segment through. And then we take our tallest point and draw another segment. They meet in the center. And it doesn't matter which of these 4 points on the circle I start with, as long as I start with one of those and count across the grid lines to the center. So I count 1, 2, 3, 4, 5, 6. So my radius is 6. And then I look at my center. My x value is -3. My y value is -1. So -3, -1 would be the center of my circle. Here we have, for number 3, circle K has a diameter with endpoints at 1, 2, and 7, -6. Identify the coordinates of the center, and then we're also going to identify the length of the radius. Here, I don't have the circle graphed for me, so I have to use the endpoints it gives us. 1, 2, and 7, -6. I'm going to connect those points. So there's my diameter of my circle. So to identify the coordinates of the center of the circle K, we've actually done questions like this before. Remember, center is another word for midpoint. So we're looking for the midpoint of these two endpoints of our diameter. So in order to get the midpoint, I can use the formula. I've already got my points graphed here, so I'm just going to count. So if I draw my right triangle down the grid lines and over across the grid line, and then I count 1, 2, 3, 4, 5, 6, 7, 8, and then across 1, 2, 3, 4, 5, 6. I go down half of 8, which is 4. And then I'm going to go across half of 6, which is 3. And that's going to give me my point at the center, my midpoint of 4, -2. Now, identify the length of the radius of circle K. Well, length is distance. And remember, Michael Jackson won the distance. A squared plus B squared equals C squared is what we're going to use. Now, to use A squared plus B squared plus C squared, we have to have a right triangle. Guess what? We already do. We went down 4 and over 3 across grid lines. So we have a right triangle here already. So we can use A squared plus B squared equals C squared with our side values here for A and B of 3 and 4 that we've already counted out. So I replace A with 3, B with 4, and C with X. So 3 squared plus 4 squared equals X squared. I plug that into Desmos and I look for my line going through the x-axis. I click on my x-intercept and I get 5 for my x value. So that is my radius. Let's move on to equation of a circle. The equation of a circle is x minus h squared. H is our x value here at our center, plus y minus k squared. K is our y value at the center, equals r squared, our radius squared. So it's not important to remember so much the minus as it's the opposite sign. Here, if you look, h and k, we don't know what they are, but we don't see a negative sign here, but we do see a minus sign there. So whatever they are in the center, it flips. So our center is HK, R is our radius. So we take our center and we flip the sign. Positive becomes minus, and for a negative, it'll be plus, and we square the radius for the other side. So let's practice a little bit with this. Given the center and the radius or diameter of the circle, we're going to write the equation of each circle. So here we have our center, -4, 9, and our radius is 3. So I'm going to start out by writing my equation, but I'm going to leave big blanks right here. So I know I have x, I'm going to flip, then I have squared, plus y, leave a space, we're going to flip that y value, squared, equals r squared. So I'm just going to start left to right. Our center, our x value is -4, so I want to flip that. It's going to be plus 4. Our y value is 9, so I'm going to flip that as well. So we have -9. So x plus 4 squared plus y minus 9 squared equals, and then I need the radius squared. So the radius is 3, so r squared is 3 squared, or 9. For number 2, again, I start out the same way. I'm going to write out the basis of my formula here, but I'm going to leave blanks. So for x, I see my x value is 2. It's a positive 2, so I'm going to subtract 2 right here. And then I have a 0. So I could put -0, but mathematicians are lazy. We don't write what we don't have to. So -0 doesn't change y. So we really just don't put anything there at all. So here you'd usually see just y squared equals the radius squared, Our radius is 2, so r squared would be 2 squared, or 4. So x minus 2 squared plus y squared equals 4 is the equation of this circle. For number 3, once again, I put out the basic part of my formula, write that out, and then here with x, I take my x value and I flip it. So minus 3 becomes plus 3. Our 5 becomes minus 5 with y. And then it says our diameter is 2. So we're not given the radius this time, but notice the diameter is not in this formula. So do you think we use diameter? Nope, nope, not gonna happen. How about no? Absolutely not. So we do not ever use diameter. Diameter is our geometry dirty word. So we don't use it. Whenever we see diameter, we mark it out and we find the radius. So our radius is half the diameter diameter divided by 2. In this case, it's going to be 2 divided by 2, or 1. So r squared is 1 squared, or just 1. When given the equation, we can use basically the same thing to get our center and radius, and we can use our radius to find the diameter. Let's start with our center. For number 1, we have x minus 2 squared. So I'm going to take that minus 2, and I'm going to flip that to a positive 2 in my ordered pair. So for my center, my x value is going to be positive 2. My y value, here I have y plus 9 squared. So I'm going to take this plus 9 and flip it. So it becomes minus 9. Now remember, it equals the radius squared. So the r squared is going to be 16. To undo a square, we take the square root. So r is going to be the square root of 16, which is 4. For our diameter is the radius times 2. And 2r here is 2 times 4, which gives us 8. For number 2, we know we're going to get an ordered pair for our center. And here with x, I've got plus 5. So I'm going to flip that sign. So positive 5 becomes negative 5. Here beside y, I have nothing. Remember, nothing is the same as 0. So that's what I'm going to plug in for my y value here. And it's equals 100, which is r squared. And to undo our square, we take our square root. And our square root of 100 is 10. For our diameter, we multiply by 2. So 2 times 10 is 20. For number 3, we have x plus 2 squared plus y minus 8 squared equals 8 squared. So x plus 2, in our ordered pair, our plus 2 becomes a negative 2. Y minus 8 squared, so minus 8 becomes positive 8, equals r squared. R squared here is 8 squared, and to undo that, we take a square root. The square root of 8 squared is 8. Our diameter is the radius times 2, or 2 times 8, which is 16. So for this one, I want you to try this. So we're going to go through one by one. We're going to try it out, and then we're going to check our work. So pause the video right here and try number 4. All right, so we should be unpausing after number 4. We should have number 4 finished. And we're going to move a little quicker through these because we're checking our work. For number 4, our center, we have plus 12 with x, so that's going to be negative 12, plus 1 with y, so that's going to be minus 1. So negative 12, negative 1 would be my center. My radius, remember, it equals r squared. So r squared is 9. So our radius, it will be the square root of 9, or 3. Our diameter 2 times our radius, which is 2 times 3, or 6. All right. Give yourself a pat on the back if you got that right. If not, that's okay. We can still have time to practice. So pause it again right here. Do number 5, and then hit play when you're done. All right, so number 5, let's check it out. We have x plus 6 squared plus y minus 3 squared equals 45. The center, we are going to take our plus 6 with x, and we're going to flip it. So our x value is negative 6. We have y minus 3 squared. So we're going to take our negative 3 here, and we're going to flip it, plus 3. So negative 6, positive 3 is going to be our center. Our radius, remember, this is r squared, so r squared is 45. So we're going to take the square root of 45 for our radius. Now, that's not a nice clean whole number. It is a decimal one. That's okay. We're going to round to 1 decimal place, so it is 6.7. Our diameter, we take 2 times the radius, or 2 times 6.7, which gives us 13.4. All right. And let's pause this one more time and do number 6. Hit play when you're done, and we'll check our work. All right, we should have number 6 finished. If we look at x here, we have x squared. There's nothing there. Nothing is 0. Y squared, nothing there beside y. Nothing is 0. So our center is 0, 0, otherwise known as the origin. Our radius here, remember this is r squared, so our r squared is 5 squared. We take our square root to get our radius, and the square root of 5 squared is 5. For our diameter, it's the radius times 2, or 2 times 5, which gives us 10. All right, for our last couple of examples, number 7, we have circle P with the center at negative 4, 9. Which equation could represent circle P? We're going to choose our answer, and then we're going to write it in Desmos to check and make sure that we're right. So here, I want to flip the center. So negative 4 is going to be a plus 4 with x, and positive 9 is going to be a minus 9 with y. So first, I look at the plus 4 beside x. A has minus 4. That doesn't work. B has a plus 4. We'll keep going. C has minus 4. Nope, not what we need. And D has plus 4. So let's check our y values. We want y minus 9 squared. If I look at B, we have plus 9. That doesn't work. But D, we have minus 9. So that works. We're going to plug it in Desmos just to be sure. We should have a center at negative 4, 9 if we got the right answer. So if we plug all of this into Desmos, here, I'll plot my center. I want to make sure that's right in the center of the circle. I write the whole equation out. And if you look at our picture, our little red dot right here for negative 4, 9 is the center of our circle. So it looks like we did get that one correct. Last one, number 8. Given circle A with center at 5, negative 5, and a diameter of 20, which is an equation of A. So here we have our center at 5, negative 5. So remember, we want to flip that. So we want, instead of 5, we want x minus 5 squared. And that doesn't help me narrow this one down any. That's okay. Let's look at y. So we have negative 5. So we're going to want to flip that. So we want plus 5 beside y. That still doesn't help me narrow it down any. We have diameter of 20. Remember, diameter is our dirty word. We don't use it. We want radius. So the first thing I do there is I change it. The radius is the diameter divided by 2, or 20 over 2 in this case, which gives us 10. Now, remember, it's not going to be equal to the radius. It's equal to r squared. So the radius squared is 10 squared, or 100. So that looks like we are looking for answer choice B. We're going to plug it in Desmos to be sure. I'm going to plot my center, 5, negative 5, and then my equation in the second box here. And you see we have a center at 5, -5 right there. It is the center of the circle. And it looks like here, from 0 to 20, we've got 5, 10, 15, 20. So each of our grid lines on this picture is 5. So here, if I go from center to the outer edge, 5, 10. I have a radius of 10. That one looks pretty good. All right. If you have any questions, feel free to ask. Otherwise, let's practice.